Okay, folks, here is the review for Chapter 5. I thought I'd do something a little bit different, just work backwards from 20 to 1, just for some giggles. So I wanted to go ahead and first look at 20. We need to write this in a polynomial function. Here are the zeros, and as you know, you go from zeros to factors to polynomials. So let's get the zeros. There they are. Here are the factors. Now let's multiply these two together right here, and then these two. So when you FOIL, you're going to have x squared, negative 4x and positive 2x for negative 2x, and then 2 times negative 4 for negative 8. Here you're going to have x squared, negative 4x and negative 3x is going to be negative 7x, and negative 4 times negative 3, positive 12. Now we get to go ahead and distribute all of this through here, negative 2x through there, and negative 8 through here. So here we go. X squared all the way through. We're going to have x to the fourth minus 7x cubed plus 12x squared. Negative 2 all the way through. Negative 2x to the third. Positive 14x squared. And negative 24x. Now negative 8 all the way through. Negative 8x squared. Positive 56. And negative 8 times 12, that's going to be negative 96. Combine like terms, nothing with x to the fourth. Negative 7, negative 2, that's going to become negative 9x cubed. 12x squared, 14x squared minus 8x squared. That's going to be, let's see here, 26 minus 8, we'll leave it with 18x squared. And let's see, those are done. Then we're going to have negative 24 and 56. That's going to be 32x minus 96. Next one, take a look. We have, I'm going to try and move this thing here. They're asking us to consider the leading term of each polynomial function. What is the end behavior of the graph? Well, remember we had that little diagram, plus, minus, even, odd. And we create a little table there. And we're going to have up, up, and then down, down. Sorry about my new marker here. And then we're going to have down, up, and then up, down. This is negative, odd. So negative, odd is going to be up, down. Number 18. It says write this in standard form. Well, let's go ahead and distribute it and put it in standard form. It's not that hard. Negative times negative is going to be positive, so I'm going to have 2x to the fourth. Remember, you are adding the exponents. So it's going to be positive 2x to the fourth. And then negative 2x squared plus x cubed. It's going to be negative 2x, remember to add, to the fifth. Now, this is not in standard form because you're going to have to put this in descending order. So over here, we're going to put this in descending order. Negative 2x to the fifth plus 2x to the fourth. Number 17, they're asking us to they want us to find the zeros of this equation. So let's find those zeros. Get my pen here. Let's find the zeros. Now, this is something we cannot factor, and it's not a quadratic, so we can't use the quadratic formula yet. But let's take a look at, since this is a 1 right here, we might be able to find some nice p's and q's. So I'm going to put all the factors of -6 over the factors of 1. That's going to look like this. Positive and negative, 1, 2, 3, and 6. All over positive and negative 1, which in essence gives us positive and negative 1, 2, 3, 6. When you plug all 8 of these numbers in here, what you will find is that you have a 0 at one of these possible rational roots. So let's go ahead and plug these into the calculator. I'm going to have to plug in all of those. I'm going to hit my stat button, edit, and then plug in 1, -1, 2, -2, 3, -3, 6, -6 into the L1. Then I need to make sure that my function is in the Y screen, which it is. So now I'm going to go back to my home screen and pull up Y1 by hitting vars, yvars, enter, enter. Parentheses, yes, you need those. Second L1, close parentheses, store this in L2. So I'm going to go ahead and hit enter, and it looks like I have a couple zeros right here, so I'm going to hit stat edit to find out where the zeros are. Lo and behold, they're at -2 and 3, so now I get to use those in my reduction of this quartic into a quadratic. Shrink this for a second. Wait a minute, those are -2 and 3. Let's don't forget those. So I've got -2 and 3 as my synthetic divisors. So now what I have to do, I'm going to give myself a little bit of room here to do some synthetic division. I'm going to go ahead and write down my coefficients. 1, 0, because we're missing the cubic term, -6, -7, and -6 again with the synthetic divisor of, let's just start off with -2, that's fine, doesn't matter which one. Get the first one for free, multiply, add, multiply, then add, multiply, then add, multiply, then add. And yes, we should have gotten a 0 here. Now let's go ahead and divide this again by 3 because that's our last divisor. And we're going to get the first one for free again. Multiply, then add, multiply, then add, multiply, then add. And yes, we get another 0 at the end. But remember, we started off with a quartic down to a cubic. Now we're at a quadratic. So I'm going to have to go ahead and plug this remaining quadratic into the quadratic formula. So I'm going to have -b plus or minus the square root of b squared minus 4 times a and c, all over 2a. I'm skipping a couple steps here, but we're all big boys and big girls. We should be able to follow along with the quadratic formula. So this is going to simplify to -3 underneath here, and I'm going to kick the negative out as an I. So I'm going to have -1 plus or minus that I, radical 3, all over 2. And these are our final two solutions. Here are 2, and here are the other two, -2 and 3, and of course, my values for x here. Let's all find the zeros here. Similar, we're going to go ahead and take all the factors of 75, put them over the factors of 2. And create our entire list of possible rational roots right here. Whoa, a little crazy there. Sorry about that. So our possible rational roots are going to be these following numbers right here. plus or minus 1, 3, 5, 15, 25, 75. Those are done. So now I'm going to put 1 over 2, 3 over 2, 5 over 2, and so on. So it's going to be still positive or negative 1 half, 3 halves, 5 halves, 15 halves, 25 halves, and so on. And you're going to plug those into L1, plug this function into Y1, and then on your home screen, you're going to pull up Y1, parentheses, L1, store in L2. Well, I've got a little bit of a spoiler alert. We're going to find out that the roots that we're going to find in here are going to be 1 and 3 halves. So this is going to be our first synthetic divisor, and then our second synthetic divisor. I'll move this here, down here, there we go. So let's get our first set of coefficients. We're going to have 2, negative 5, 53, negative 125, and 75. So we get the first one for free, as we know. Multiply, add, multiply, add, multiply, add, multiply, then add. Divide again. First one for free. 3 halves times 2 is going to be 3. Add, 0. Multiply, 0. Add, 50. 1.5 times 50 is going to be 75, and that's going to leave us with 0 when we add. So now we're left with this 2x squared plus 50, correct? So I'm going to go ahead and give us a little bit of space here. There we go. To go ahead and solve this relatively simple quadratic, I'm just going to go ahead and set this thing equal to 0 because we don't need to worry about using the quadratic formula because it's such a small quadratic. Set that equal to 0, subtract 50, and divide by 2. And we're going to have x squared equals negative 25. Then take the square root of both sides. Kick our I out, and then the square root of 25 is 5, so that's going to be 5i over here. Remember, that's plus or minus, and that's what x is going to equal. So we found our two solutions, 1 and 3 halves, and then the other two, plus or minus 5i. Find all the roots of this equation. One thing about these is that it kind of looks like a bunny because there's nothing out in front and it's got 3 terms. It's not a quadratic, it's a quartic, but I think we can factor this using the idea of a bunny. Instead of putting x right here, just put x squared. Then find out what are my factors of positive 8 that add up to negative 6, and we find out that that's going to be negative 4 and negative 2. Then set each one of these factors equal to 0. X squared equals 4. X is going to equal positive or negative square root of 4, known as positive and negative 2. Here, we're going to set x squared equal to 2. That is not a 2. This is a 2. And then we're going to take the square root of both sides, and x is going to equal positive or negative square root of 2. So we have 2 solutions here, 2 solutions here, and we're done. How many roots do the following equations have? Well, kids, if you haven't caught on now, roots is the same thing as zeros and the same thing as solutions. How do we determine how many solutions, zeros, and roots? Look at the biggest exponent. Yes, it's going to be 4. Simple enough. Let's move on to 13. Find the roots of the polynomial equation. Well, here's a fun and dandy one. Thank you very much. See if this will move it. Of course not. So let's think about this. Is this something we can factor right away? Well, we could probably corral these puppies, but there's nothing that we're not going to